haven't seen that.
They're like civil engineers.
Oh, really?
They're like architects or something.
I saw someone.
Pictures of benches and stuff.
Yeah. They were talking about like the structural supports.
Oh, okay.
So why did you guys go with this cable system instead of?
Interesting.
Yeah, it is interesting.
Well, I got a clipboard. I can probably go like hang with them. Like, well, let's see.
All you need is a clipboard and a cell phone.
Yeah,
Pictures.
totally. Yeah, when I was walking in, there was someone standing on the end, just kind of like looking and like watching people as they walk by. I'm like, is there something going on? All right, so questions other than clipboards and cell phone. Did we talk about jar files in here or not?
Briefly? Yeah, very quickly.
Did we talk about how to make a runnable jar? I think I skipped it in this section. Okay, so let's go over that. Because that's useful.
Wow. That's visible.
That's, yeah. Slowly.
It changes the window size.
Resize it. You can fix it now. Resize it.
Why are you laughing? That's easy.
Come on. All right. So there's a new command available on the server called AskCon. You can ask Con about it if you want. So that's up and available for your viewing pleasure.
How does it work?
You say AskCon and it gives you a fortune or a bit of wisdom. So, and it's topical to us. So that's available. Thank you. Let's look at something in Eclipse here. So you're playing in Eclipse, you've got a piece of code you're really happy with, so here's the code I was playing with to experiment with growing buttons and resizable windows. And let's say you want to give that to somebody who doesn't have Eclipse and doesn't know about Java-C and all this kind of stuff. You want to create something like just an exe that can be used by itself. So here's the general approach. So go to your project, right-click on it, and say Export. And this time in Export, instead of General, go down to Java, expand on that, and then you want runnable jar file. And this is different from a plain jar file, so it's the last entry on mine. So runnable jar file, say Next, and then you have to specify what it calls launch configuration. So this is my grow program, and I want to use the class main. So that's the thing I wanted to execute, and you can put in a destination to write the jar file, and I'll just put it into haha.jar. And this operation repacks don't show that again because I don't know what it means. All right, and we'll ignore any errors that pop up, and let's go ahead and close this.
I think it's saying like if you included a library.
Yeah, make sure you can include it.
Make sure you have the rights to that library.
Yeah.
If you're going to do something with this file.
Right. That makes sense. All right, so if I look at wherever I exported, haha.jar, so if you say java-jar and then the name of the jar file, that should execute it. And it brings up your window and it should behave the same. So this is useful for a few things. One, if you're making a game or something, right, and you want to just sort of like let people be able to run it. As long as they have a Java command, they can run it. They don't need the development kit, they just need the runtime environment. But also when you're working on your calculator for PA3, once you've got something that you think is pretty solid, if you want to pass that to other people and have them try to break it, or see if it works, or see if it makes sense, You can pass around jar files, just don't compile with the source code, don't use the -G switch, and this should be just executable code, so it's not like you're giving your source code to somebody.
Is it clickable in the file system as well, or do you have to
Well,
execute the command line?
depends how brave you are. So let's see, what happens if I just click? That's not gonna work. What if I say open with? So I can open with the runtime environment. That's not gonna work.
Okay, so that's what we're running.
So there's probably some way you can do it. But I don't know. Java-jar definitely works. So.
Okay.
All right. Does that help with jar files? All right, so let's take a quick look at window managers. So let's make a new project. And let's make a J-frame. So there's my my J-frame. By the way, if you start messing around with archives and stuff, sometimes when you open up something that should have a design tab, it won't have a design tab. If that happens, you can say open with window builder editor, right, and that'll restore it. Sometimes you get tons of errors, right, where things like JFrame and JPanel aren't understood even though they're included. And if that happens, here's something to try. Go to Project and Properties. So this is something you don't want to mess with unless you really feel like messing with it. But if you go down to Java build path, this basically says what Java package are you going to use to build your code, to execute it, and so on and so forth. And I was messing around. I decided to set this to an open version of Java just to see how that worked. And for me, it's not working very well. So I'm using Java 8 OpenJDK 64-bit version. If I come down here and I just say Java 1.8 and apply that, that makes my system happy. So if you don't change anything, that shouldn't change on you. But if you switch environments or an upgrade happens or something like that, sometimes that's where the weirdness is coming from. And this properties window, by the way, lets you do all kinds of customizing of Eclipse. How deep you want to go down that rabbit hole is totally up to you. But the editor, for example, you can, well, I'm not going to go down the rabbit hole. But you can set things like color coding and automatic indenting and what kind of corrections you wanted to make and what suggestions you wanted to make and stuff like that. It's all more or less tailorable. And once you get a configuration you like, you can save it in a configuration file and then pull that in when you have a different Eclipse install and so on. No doubt we could do at least one whole course just on Eclipse, just on learning how to use it. I'm not going to go that deep into it, but you're welcome to explore it and play around with it. Alright, so layout managers. I like the group layout. So if you click on swing group layout, just left click, come over here. It's not going to let me drop it. Maybe I don't like the group layout. Maybe that's weird. This worked earlier. try this once more and then we'll give up. Alright, so I'm going to do a group layout. I'm going to drop that in here. And in my code, it's basically creating a group layout, right, which is a thing that we can put widgets in, but we can control what these widgets do when things change size. So let's drop a button down here. So there's a button, and if I select this on the top, it's pretty hard to see, but there's a little thing pointing up, and over here is a little thing pointing left. Those are the anchors. So this button is anchored to the top and the left of this pane, which means if I run it, it looks like resizing doesn't do anything, but actually what it's doing is it's keeping at a fixed distance from these two edges. So let's see if this will work. So if I say anchored right, and I run it, now when I move my window and I change size, it's always a fixed distance from the right side and a fixed distance from the top. And I can set the top bottom anchor to say anchored to the bottom. And now it should always be a fixed distance from the bottom and the right. Alright, now if I make the top bottom one auto resizable, it will scale it vertically while staying in a fixed position horizontally. And if I make them both resizable, then I've just got a plain old resizable button that keeps kind of the same proportions. And so if you've got multiple buttons, and I don't know what it's doing when it's like grayed out like that, it's thinking about something. But if you push it while it's trying to think about this stuff, sometimes it seems to break it forever. Like if I drop more components, it may not come back. And for me, this only seems to happen on the second component. And then after that, it's fine. Well, we'll give it a minute. But if you put more components on there, you can make them all resizable, and then they should kind of grow and shrink as the window itself grows and shrinks. And that may be all you need for the extra 5 points on the calculator. But window managers can be finicky sometimes. The absolute layout manager, you really don't have a layout manager. You're just placing things in absolute XY coordinates. When you do something like this, then you've got something in the background that's trying to respond to those changes. I seem to be pretty solidly stuck. Alright, let's put down one more button right there. So let's make this auto resize. And auto resize. And let's run this. And we've got 3 buttons, and oh, my top one stopped resizing. There's probably a reason for that. Oh, it's because the bottom of these buttons is connected to the top of this one. So I think you got to mess around with it. All right. Well, anyway, that's the idea. Play around with it if you like. This is why it's bonus points. And there's lots of different layout managers. I've had some good luck with spring layouts, and you've got to learn how to use struts and springs. But you can basically place things between widgets that are either rigid, so they always keep the fixed distance, or springy, so they keep a relative proportion in the layout. right. Anybody look at hash maps? Anybody look at hashes? All right. So we started looking at this yesterday. So a hash map implements a hash. There's hash maps and there's hash tables. They're more or less interchangeable unless you get into weird situations. Hash map lets you have null keys and null values. There might be reasons why you want null values. Null keys are kind of quirky. But if you want to do it, you can do it with a hash map. You can't do it with a hash table. Probably next week we're going to start talking about multi-threading, running multiple processes at the same time. And this is where we're going to get into questions of how many things can interact with an object safely. Everybody sign in. If you've got multiple threads running and you're trying to share the same objects, you can't use a hash map without doing some extra work, because it says it's not it's unsynchronized. But we'll get into that next week. So Hashmap Hash-Table, basically interchangeable for now. So you construct it with two parameters, right? So hashes have two pieces of information. There's a key and there's a value. And the idea is the value is associated with the key, so you can load in key 1, value 1, key 2, value 2, and then you can retrieve your values by going in with a key. And it's kind of like a glorified array, except your keys don't have to be consecutive integers starting from 0. Your key can be anything, it can be any type of object. You could key this off of rectangles. You could go in with 5x5 rectangle and you could pull out, a color associated with that, or a linked list, or whatever makes sense for you. So construction you do without arguments, you just call hash map. And then mostly we're going to do get to put in a key, get back an object, or put a key in an object pair. And we can delete with remove. All right, so let's start off with the simplest. Let's just hash keys and data values that are strings. So that's our constructor. So we're just going to call our map. And so let's throw some things into our map. So we'll use the put method. So we're going to teach this thing how to talk. So hello is a greeting. Goodbye is a greeting. How are you is a question. I am good is an answer, and so just random stuff. We're just taking some phrases and we're trying to categorize what kind of phrase this is, and so we're storing this in a hash. So let's see what's in our hash. So while there's another line of input, let's read a line. Let's use the get method on our map and see what value is associated with that key. Alright, so this is just a basic map exercise. So we can throw some values in, then we're just going to read input from the user, throw it into the hash, see if it matches to anything. Alright, so let's go ahead and build this and run it. I didn't put a prompt in, so we say hello and it tells us that's a greeting. We say I am good and it tells us that's an answer. We say how are you and it tells us that's a question. If we say blah, the value comes back null, didn't find it in the hash. Okay, so what is this? This is a way to be able to store whatever kind of information we want and associate it with whatever kind of keys we want. And so if you were making a language program, maybe you could characterize information about sentences or words or paragraphs, right? And we can have an arbitrarily long key, and anytime that key pops up, we can find some piece of information associated with it. If we were making MATLAB, where we have variables, we could make a hash where our keys are the names of the variables and the values associated with them are the values of the variables. And when you want to print the value of x, we'd go into our map, we'd say, tell me the value associated with x, we'd get a number, and we'd go ahead and print that out. You can do all kinds of things with hashes. So how could you use this if you were redoing PA2? Could you make good use of a hash?
Yeah.
What would you do?
Don't think about it.
Okay. What was the point of PA2? We were building an index of words, right? So grab a word, and if we've never seen it before, we just record the location where we saw that word. If we've seen it before, we want to build a list of all the locations, so we want to tack the current location onto the end of a list.
You could just hash its index number to whatever word it is. So your word could be your hash key, right?
Mm-hmm.
And then your index number could just be whatever you're sending to that. So you would have your key associated with all of its positions.
Okay, how would we associate it with multiple positions? I like the idea of using the word as a key.
So we could use our, maybe a misunderstanding how we use the put function, right? But whenever we find a key that we don't have, right? So if our key would return null, we have the key. And then whenever it is there, we would put the number basically where like, are you hungry? And then hash it to the item. And then you have your list of your numbers associated.
Oh, okay.
with each
So
key,
just
right?
string them together side by side. Sounds good. The other thing we could do is we could make the data item a linked list,
Oh, yeah.
right? Using the linked list class. And then we could just say add to the end of that list. or you just make it a string. So with hashes, if I were to re-put something on the same key, right, it replaces the old value, right, just like a regular hash. So you can only store one thing. You can only store one value associated with a key, but that value, of course, can be, you know, a string, a list, a hash table. It could be something much larger. So most of these are obvious, right? We can get size to see how many keys we have stored in the table. We can remove objects by using the remove method. Let's take a look at key set. So the thing with hashes, and we had this when we did hashes last quarter, is there's no sort of natural ordering to the keys. There's no way we can make a for loop and say, give me all the stuff in my hash, right? With an array, we know our indexes start from 0 and they go up to the number of things in the array minus 1. So we can make a for loop and say, give me element 0, element 1, element 2. With a linked list, we can start with the first element, say, give me the next, give me the next. Even with a tree, we can say, give me everything on the left, give me the root, give me everything on the right. There's no sort of natural way to do that with a hash, because a hash doesn't have any kind of internal ordering to things. It's just a big thing that holds key value pairs. But it's kind of an abstract notion. It's kind of like a set. If you just have a set of things, there's no inherent order to them. So saying, give me the first thing in the set doesn't really work. So there's this concept called an iterator. And an iterator is like this next and has next pair that we used with scanner. It's a way to say I want to pull things from this structure one at a time in whatever order you choose, but I want to make sure I get everything exactly once. And so there's a hash method called keySet, which returns a set, which is another type of object, containing all the keys. And it's like a CSE215 set, right? It's just an unordered collection of keys. So we can't make any assumptions about it. But we can create a set of keys by saying, get keys.
How does this set method find all the pairs?
So get keys is what's finding all the pairs, and that's part of the Hashmap class. So when you write the code for everything in a hash map, you also include something for getting the keys.
So how does the method get keys work? Do you know?
We don't know. We could look at the source code. If I had to guess, it would, if we were implementing a hash with an array, right, and we had a flag that said valid and a flag that said deleted and a flag that had, right, we would just go through the array from beginning to end. And the order in which you get them would probably appear random, because if you take the keys ABC and insert them ABC, they're usually not going to end up ABC in the table. It depends where the hash function maps them to. So it's doing something internally. All right, so that's going to give us a set, and a set has this thing called iterator. So Java util set. And sets are a whole useful class in themselves. You can add things to the set, you can search for things in the set, you can remove things from the set, right? And it's just another way of storing and retrieving and keeping things. But they come with this iterator method. So the iterator returns an iterator. So let's include that also. Alright, so we started with a hash map. We got the set of keys. That's a set we're calling all keys. We're calling the iterator method, which is giving us an iterator for that set called IT. And we can say, well, IT has next. And I think I'm going to need to do this. So this should give us the keys one by one. I really don't know if it's going to work. Didn't like my get keys. Key set. Alright, ready? There you go. There's all the keys in our hash map. And if we want to print out the value along with the key, right, we can just use the get method, feed it that key, and it should return to us the value. Does it make sense? And we don't have to be overly wordy. Alright, so we can put these things together. Take our hash map, that's map. Get the set of keys, that's what key set returns. Get an iterator for that set, that's what iterator returns. And we can just assign that to an iterator. That's designed to take strings and then start using that. And these can go further and further and further. And you can end up with lines that have, 16 function calls, 16 method calls, strung out side by side, and that's perfectly fine. Questions about this? I can't tell if it's clear or it's vague and bizarre. So when you construct a hash map, it's given some reasonable size initially. You can specify an initial size yourself, or we'll pick something reasonable. But there's this concept of load factor, which is roughly how likely you are to get a collision, right? And the fuller your hash is, the more likely collisions are. If you've only got a few things in your hash, and your hash can hold 1,000 entries, that's pretty empty. So your load factor is just how many of your cells are full, basically. So default load factor of 0.75 is when it decides this hash is getting too crowded. And when that happens, it'll go ahead and it'll expand the size of the hash. And you can explicitly do this with something. I think it's somewhere else. Anyway, you can expand it, but if it gets to be 75% full, it will automatically expand. And so how do you grow the size of a hash? How do you make this thing bigger?
Create a new larger hash and then just feed everything into it.
Yeah, create a new larger hash, and then you can just rehash everything that's already in your old table. If you have a larger table, you've got a different hash function, because it's got to be able, assuming we're mapping into array indexes, you're going to have a different function so that you can access more locations. So the mappings from the old table won't just go over to the new table, but you can rehash everything. And a lot of times you can do that in the background, right? So you're trying to store one more thing in the hash. Well, you can start a rehash process in the background. And then when that's done, you can just switch over to using that new table. And you make it big enough so that your load factor starts off low again, and it builds slowly. All right, well, so let's talk about threading. So we'll get into this for real next week, but let me set it up for you. In C, we talked briefly about the fork method, the fork function. Right? You can call fork and you get an exact clone of your current process, except the fork returns 0 for one process, the child, and it returns a process ID for another, that's the parent. So it knows who the child is. And then you have 2 copies of your program executing. And you can use that to write code that has multiple things happening more or less simultaneously. And we can do the same thing in Java, but in Java it's a lot easier. Okay, it's got a really slick mechanism for creating these multiple processes. So these are called threads. And the idea is we start off with our main method, right, public static void main running, and that's a single thread. And it can request other threads to start and execute other methods of our choosing. And these threads are running more or less simultaneously. So here's main. And at some point it can do something like a fork, and you have a second process. And this doesn't have to be a clone of the first one, like with fork. And I say more or less simultaneously because are those 2 threads actually executing simultaneously? It's hard to know. It really depends on the hardware. So if you got one CPU and a single core, you don't really have multiprocessing. You've still only got one thing happening at a time. And the operating system switches off what process is being executed. And every, I don't know, 10 milliseconds, something, It will stop what it's doing, put aside all the contents of memory, the values of the registers, the program counter, the stack pointer, all of that stuff, save that somewhere, pull out the context of another process, start executing that. Run that for a little period of time, and when that's done, put all of that aside, switch back to the first process. And if you got 200 processes running on your system, it does that. 200 different processes, goes back to the first eventually. If you've got multiple cores, then you might have 2, 3, 4 processes running at once, and you're sharing off among the set of active threads. If you've got something like a GPU, which has a few thousand cores, right, you might have 1,000 processes running that are actually running simultaneously. And all of that complexity is handled for us to some degree by the Java virtual machine. It takes care of scheduling, it takes care of swapping things in and out, knowing when a process is finished, and so on and so forth. What it doesn't take care of for us are questions of synchronicity. And we can get into problems where we have 2 processes running and they're not playing together nicely. And there's a few scenarios for that. So process A and process B are running along, and they're executing code independently, but they also have some shared memory because you want these processes to communicate with each other. So for example, suppose that x is a variable that both processes have access to. So this process says x equals x plus 1, and somewhere this process says x equals x plus 1. And if x is equal to 5, when process A finishes this, x should be equal to 6, and when process B finishes this, x should be equal to 7, right? And if B finishes first, x will be 6, and then when A does this, x will be 7. But either way, when both of these instructions have executed, we expect x to be 7. But here's what can happen. This x equals x plus 1 is actually 3 steps. The first step is to read x, and then increment the value that you read, and then write x. Okay, so there's one copy of x, which is 5. So suppose process A says read x, and so it says x equals 5. And then it says increment x, so now it says x equals 6. And at that point, the JVM decides time for process B to run. And process B starts running, and it says, this isn't x, it read x equals 5, and it incremented to 6, but it hasn't written it yet. Okay, now process B runs, and it says read x, and it sees x equals 5. And it says increment, so now it's got a 6 in its internal register, and now it says write x, and so now x is equal to 6. And now process A continues running, and the last thing it had done was increment 5 to a 6, and now it says write that value into memory, and it writes a 6 here. And now both of these x equals x plus 1 instructions are done, but x is only incremented once. And this is a classic problem, and it's really, really hard to cope with unless you have some kind of hardware level support. So that's one problem we're going to deal with. Another problem is what's called deadlock. So both processes want to access the same resource. Typically, you grab the resource, you put on a flag and say, I've got this resource, it's in use, nobody else touch it. Right, that works fine. Suppose you have 2 resources. I want access to the mouse and the keyboard. And you also want access to the mouse and the keyboard. Okay, well, I ask for the mouse first, and it says, yep, no one's using the mouse, so I take the mouse. And at that point, your code starts running and says, I want access to the keyboard. And it says, no one's using the keyboard, you grab the keyboard. Okay, and now your code says, okay, now I want the mouse too. Well, if someone's got the mouse, you gotta wait for that. So you're waiting, code goes back to me, I've got the mouse, my code says, okay, and I also want the keyboard. It says someone's got the keyboard, you gotta wait. And so my code is suspended until the keyboard's free. And we're stuck, right? I can't go forward because I don't have the keyboard. I can't get the keyboard because the person who has it can't go forward because they need the mouse and I've got the mouse. All right, so that's deadlock. And that's a really hard situation to predict and somewhat to deal with. And this is the kind of thing where your code might work great for a week, and then all of a sudden one day it just freezes up. And it's because a peculiar combination of timing and circumstances came up, and now you've got a deadlocked state. So we'll talk about that. We'll talk about the dining philosopher's problem as a way to explore deadlock issues, and all this other stuff. So we'll start doing multi-threaded stuff on Monday. All right, enjoy the weekend. See you then.
Nick,
Yeah.
are you gonna post